sklearnmetricspairwisesigmoidkernel. Description: the sigmoid kernel is a similarity function that takes two vectors as input and returns a value between 0 and 1, representing their similarity. It is based on the sigmoid function, which is a smooth S-shaped curve. The sigmoid kernel is often used in machine learning to measure the similarity between data points. It is particularly useful in applications where the data is nonlinear, such as image recognition or natural language processing. Inputs: X, a 2D array of shape n samples. N features, representing the first set of data points. Y, a 2D array of shape m samples. N features, representing the second set of data points. Outputs: kernel, a 2D array of shape n samples. M samples containing the similarity scores for all pairs of data points. Steps: the kernel function first calculates the dot product of each pair of data points. The dot product is then scaled by a factor of gamma, which is a hyperparameter that controls the width of the sigmoid function. The result is then passed through the sigmoid function, which produces a value between 0 and 1. Metrics: accuracy measures the percentage of correctly classified instances. Precision measures the proportion of true positives among all instances predicted as positive. Recall measures the proportion of true positives among all actual positive instances. F1 score harmonic mean of precision and recall. Visualization plots: heatmap a visualization of the similarity scores between all pairs of data points. Scatter plot a visualization of the data points in a 2D space, with the color of each point representing its similarity to other points. Fine-tune parameters. Gamma controls the width of the sigmoid function. A larger gamma value results in a wider sigmoid function and more similarity between data points. Uncertainty methods. Monte Carlo dropout samples multiple outputs from the model by randomly dropping out neurons. During training and prediction, the uncertainty is estimated based on the variance of the outputs. Bayesian neural networks uses Bayesian inference to estimate the posterior distribution of a model parameters. The uncertainty is estimated based on the variance of the posterior distribution. Challenges and fixes. Challenge 1: overfitting the sigmoid kernel can overfit to the training data, leading to poor performance on unseen data. Sample use case that resulted in challenge 1: using the sigmoid kernel to classify images. But the kernel overfits to the training images, resulting in poor classification accuracy on new images. Fixes to challenge 1. Regularization techniques such as L1 or L2 regularization can be used to prevent overfitting. Early stopping: stop training the model when the performance on a validation set starts to decrease. Challenge 2: data scaling. The sigmoid kernel can be sensitive to the scale of the data. If the data is not scaled, the kernel may produce inaccurate results. Sample use case that resulted in challenge 2: using the sigmoid kernel to classify text data. But the features are not scaled, resulting in inaccurate similarity scores. Fixes to challenge 2. Standardization: scale the data to have zero mean and unit variance. Normalization: scale the data to have a range between 0 and 1.